Are we live?
I think we're live.
I need to. Okay. Hello, everyone. Welcome to the Makercast. It's episode. Here we go.
38.
Feedback. Welcome to the episode number 48. I'm glad to be host again and present you two wonderful guests. We have Pat, who is the first time on the Makercast, and we have the Shipu, who is also showing his nice inventions again. So, what is the Makercast? If you're first time on the stream, it's basically open, quite open podcast where we just some makers can join and show off their creations, and basically we talk about this for a few seconds and present our stuff, and that's about it. Very casual. We are doing it for a few years now already, as it seems it's now like 4 years. Yeah, so first of all, everyone, please introduce yourselves. So, Pat, maybe you start since you're new to this. So,
Sure.
who are you and what are you doing?
Oh boy, who am I and what am I doing? My name is Pat Deegan. I'm the co-founder of Psychogenic Technologies, where lots of the work happens here. We basically do everything from architecture to circuit design, prototyping, PCB layout, blah, blah, blah. And then I have a little pick and place and do small batch runs for field testing, and then it goes to China. Because I end up making a lot of tools as I'm working on stuff, I ended up sharing some of it with people, so YouTube videos and stuff like that. And I ended up doing a lot of OpenPNP, KiCad videos, stuff like that. And recently I've been learning ASIC design. And that's a little bit of what I'm going to be talking about. Not the ASIC stuff, but stuff that's peripheral to that. So,
with tiny tape out?
well, it kind of, yeah. Basically, I have a tiny tape out project and it needs some external support. So that's what I've been playing with. And I'm going to show a little bit of that and also how I test it, really, how I've been characterizing.
Nice. Great. Okay. Yeah. Very interesting topic. Looking forward to that. Now, the Shipu, maybe you introduce yourself. You're a common visitor here.
I'm Radomir Dopieralski. I'm a Python programmer working in an open source company, and that's by day. By night, I build like killer robots and things like that, because the humanity is not going to go extinct by itself anytime soon. So we have to help them.
Nice. Okay. Yeah. I also need to introduce myself. I'm Bitluni, known as Bitluni. My friends in real life also call me Looney, even though my name is Matthias, and I'm doing this full time. Even though sometimes it doesn't seem like I publish very much, but in the background, I'm doing a lot of maker related stuff on my channel. Yeah, that's about it from me. And now we will just go around, and everyone will show off what they have to show today. Pat, you can show whatever you like because you're the first time. Usually, if we have like people that are coming back, they show like since the last time they presented something, they can basically show whatever they did since then. And now it's your turn.
Nice. Would you like me to begin? I have I've prepared a little presentation here. Where is it?
Oh, nice.
Give me 2 seconds. This. Okay. So hold on a second. I'm pointing the right thing. Yes. So like I said, I have a YouTube channel and I basically put on stuff mostly about pick and place and tools. You can see by the playlist, it's KiCad stuff and the ASIC stuff and pick and place stuff. So what I've been doing is I took a course called Zero to ASIC and started learning how to design these ASICs because I worked on a few projects and it was fascinating, but I didn't know how to make these chips. I'm only using chips. So as I'm doing the course, I end up discovering, okay, well, you can make a project and actually have it taped out. But the fastest way to tape it out is tiny tape out. And this is basically a little system where you can have a tiny project shared with others. So the way that works is when you're doing a silicone wafer, that costs like $1 billion, right? The lithography masks and all that. It's very expensive. So what happens is on a multi-project wafer, they chop it up into little bits like this. And everybody gets their own slot and they can put whatever they want in there. So Tiny Tape Out takes a bunch of those, and in each of those little squares, they stick a Caravelle framework, basically a SOC framework, so that we can have I/O and things. And then each one of those little squares in there, in turn, is another little project. So I ended up getting a project for myself in there. And what I did is I ended up deciding, okay, on Tiny Tape Out 1, 2, 3, now it's going a bit faster. The I/O is pretty slow, so I decided to do something in the audio range. So what I ended up designing was Project Neptune. And this is basically a frequency discriminator disguised as a guitar tuner. So the idea is this chip will take in some input pulses, count them, and tell you if your string is tuned. So when I did that, I did a little video and made this beautiful design. And then I ended up implementing that in digital logic using Python and Amaranth and spitting out Tiny Tape Out. Now, the thing is, I ended up doing 2 versions on Tiny Tape Out 3, and then they just did another spin out at Tiny Tape Out 3.5, where they're testing new technology where instead of going only kilohertz, we're actually going to have some speed on the I/O. It's megahertz, I think 46 or something like that is what they're talking about now. So the point is, when I did that, I tested it on an FPGA like this with a nice little signal generator. And I just basically gave it, here's 146. That's a D. Okay, great. That's cool. Except that the thing I kind of hand waved away when I was working on it was this stuff. A guitar sends out a small electrical signal, but it's small and it's super messy. So yeah, your string is at 330 hertz or 83. It's very low frequencies, but it's also very messy. So these signals need to go through a low pass filter because we don't need all that timbre, all that beautiful guitar sound. We just want to know the frequency. So you low pass filter it was the idea, and then you put it through a threshold detector, and then you get your pulses. So that's cool, except I'm not an analog guy. I mean, I'm an analog guy, but I don't really do analog. So the point is, I ended up going to one of my favorite tools here, which you can see. Let's see, where is it? Nope. This TI has a nice little filter design tool that you can use and design these filters. So that's really cool. So I just used that and pumped out basically a 5th order Chebyshev, which looks like this. So this is what the design came up with, and it gave me this thing, and it was like, okay, you can use these op amps, TI of course, and use this, and it'll give a response that looks about like this. So that's great. It's a 5th order, so the cutoff is pretty sharp. I can't have anything going in the higher frequencies because we'll get aliasing and it'll be a giant mess. So I need a sharp cutoff, and I had to go active because the frequencies are so low. So 83 hertz to 330. So I ended up prototyping this on breadboards, which is something I don't like to do very much, but now I'm a little bit more sane in my designs. I use these breakouts here like this that I can stick capacitors and resistors and stuff like that on, and it makes a pretty clean design. So basically on the right here, this is the circuit we saw earlier, the low pass filter. This is an auto gain control that is not working out so well, and this is just a preamp for testing on the guitar. So that's great. So now I have my circuit, and I decide, okay, I'm going to try and see how it works. And I did it manually. I fed it with the signal generator, and it was okay. I ended up putting it into KiCad to see, because I didn't have that op amp and I didn't have those exact capacitors and blah, blah, blah. So I just put it into KiCad and simulated that. And the response it gives me is decently similar. You can see this is 330 hertz, and then it cuts off like really quick. So that's the simulation. But what about real life? In real life, this is what I got. Now, these are actual measurements. Now, my spectrum analyzer starts at 9 kilohertz. That's way above. It's a low frequency, but it's way above what I'm looking at. So the question is, how do I get these graphs? Of course, I could go manually and just do it like a slow nightmare. But what I do is automate things a lot. So that's what I did. Now, these are various iterations I got with changing slight small components. A couple of caps are really kind of have great impact. So this is my first trial, and this is 0 dB up here, and it's going down. Second, third, it's getting better. It's flat, and then it goes down. And my low frequencies, the small cord, is actually very, it doesn't send much electricity. You know, this is a piece of metal going around the pickup, and it's a tiny cord, and it just doesn't have much impact. So this was my final design on the right here, where there's actually a boost around 330 hertz. So that's cool. So yeah, this is what it looks like up close. So demo stuff. Okay, yeah. So I'm going to show you a little bit of what I did here. So the first thing is
live demo. Nice.
Yes, yes. Well, we'll see how much it fails. But so this is my my little circuit here, and this is the simulation. And KiCad is getting pretty good with NG Spice integration here. So this is actually my LM324 op amp and the values that I measured, 17.68K and stuff like that. So I put them in to get something realistic. So one really nice thing is this tune. So one of these caps really has an impact. It was designed at 100 nanos, but if you look at that, well, okay, so there's no gain. So I reduced it so that it would boost my my high end there at the 330 hertz. This one also has some impact. Anyways, the point is, I played with simulation until I could tweak some of the values and see what I could do. And I just put two caps in line to get 100 plus 100 equals 50 in cap world. So that was that. Now, the other question is, okay, the lab instruments. Now, this is my lab right now. Where is it? Here. So you can see this, right?
Yeah.
So up on the right is the power supply, and then there's a signal gen on the bottom here, in between the two and the scope. So let's see. Okay. So what I can do is what I did. Okay. Yeah. I'll show you this first. I basically developed a bunch of SCPI or SPCI, SCPI. Anyways, lab instrument connections. So this is a Rigel DS1054, the classic Maker thing. This is a Unitrend signal generator. This is a Siglent power supply. And I basically have interfaces for all of them. And I released these. The toolkit is basically available. So if we look at the console, I'm currently connected to this machine here. Whoops. Here. Right. So what I have is this script here via test bench examples filter scan, and what it does is it comes in and it takes my equipment here. Where am I? Pitch down. So it sets up the DSO. It turns on the channels. It sets up the PSU. It turns on the output, and it sets up the signal generator, and then it sweeps through them. So we're just going to run that one shot, quick version, let's say, because we don't have a million years. So what it's doing is it just turned on the PSU, and it's playing with the scope. And what it's going to do is sweep through those frequencies. And you can see what it does is it basically changes the frequency on the signal generator and then measures the VPP. And so from the input, the yellow, and the output, the blue. And what it's doing is it's basically comparing these, and you can see on the console here, it's starting to go down and down and down because we're up above 300 and whatever kilohertz hertz. So that's cool. From there, I can basically generate, well, it spits out a CSV, and then it generates those images that you saw there. What's really neat with this test bench thing is that I have a console. And because everybody's using tools that are similar, this might be useful to a lot of people. So in this, I've got, well, I've got the power of the signal generator and the oscilloscope. If I go here, let's see, I can take the lab PSU and channel 1 voltage, say 3.2, flip, and it changes. And then I'll just turn it on, bloop, and it goes on. So what's really neat is I can tell the SIGGEN, let's see, lab signal generator. Now it's lazy initialization. So it created that object and it's connecting to it now. The signal generator is damn slow for some reason. This has code completion, so that's really neat. I can go channel 1 ... mode ... sweep linear. Now turn that on. And we don't see anything on the scope because it's currently stopped. DSO run. There we go. Now it doesn't look so great, so we're going to change the time base. Scale the frequency, let's say 500. There we go. And you can see the filter responding here. It basically goes pretty much at the same level, and then it goes up. There's that little boost at the end, and then quickly down. It's like at least 20 dB or something per octave. So that's pretty much it. If you're interested, let's see. I've got
Cool.
I've got this toolkit here. GitHub. Yeah. So basically, right now it supports my Siglent, the Rigol DS1000 and MSOs, and the Unity UTG 9XX. I'm going to put a DMM in there, also a Unitrend, and a few other things. And so this is basically open source. I mean, it's whatever. Cool. And I've got some examples in here that give you an idea how everything works. So that is my story. Any questions?
Yeah. Did you try using a sound card?
Oh, well, that's pretty good. that might work, but it would still have to get the scope to tell me what's going on. So yeah, in the end,
like just or the input of the sound card.
Yeah.
But the sound card would be good. What I liked with this, I'm not too sure. Yeah. I characterized a couple of different waveforms because the UTG has arbitrary waveforms and stuff. And those first graphs there had 4 curves because I was trying out different things. And so for some reason, the square waves are boosted. Those edges actually give it more gain. But the point is, I like having everything over there and controlling it from over here. Okay. And yeah, so that's pretty much it.
Okay, so now what's your tiny tape out ASIC doing then afterwards? Now you have the filter. This will be like in filtering the input for your ASIC, and then what's
oh, that's right. What the system does is basically because the tiny up to tiny tape out 3, we only had 8 inputs and 8 outputs. So what it does is we saw it quickly there in the thing, and I can show it again. But basically, what it does is it drives a dual 7-segment display LED thing. So it takes those 8 pins, 7 go to the segments of both, and then 1 swaps between the 2. And what it does is, as the input comes in, it's converted eventually by all this circuitry to square waves. It counts that, and it says, "Oh, you're getting close to the D string." And so you're a little high, you're straight on it. Okay. Oh, you're a little low. So you basically tune your guitar by counting the pulses in a certain period. I'm using half a second by default.
Okay, nice.
So you basically have the fixed tuning in there.
Yeah, it's standard tuning. And, I was kind of crunched for tiny tape out, and I did a few things. On the 3.5, I actually improved the algorithm. And now it actually gets more of the notes, even if there's no of this note in the standard tuning. So it'll tell you. The other thing is, it's tough because around like the big fat chord there, the E, it's 83 hertz, and 10 hertz below that is a D. Because the octaves, the doubling thing. So up above, it's easy to discriminate between 2 notes, but down below, it's really tight. So I can't even do drop D tuning because it goes, oh, that's a D, oh, it's an E. It'll choose one, but there's overlap. So it isn't that great, but it's getting better.
Nice. So do you know any news from Matt if Tiny Tape Out 2 is progressing? I mean, we had like a best case scenario August or something.
Yeah, I actually don't know. I haven't been in the loop there or haven't been paying attention because I don't have anything on 2. The real big news is the 3.5 that just came out. I mean, the deadline was a week ago or something, and it's a huge difference. You can actually get bigger tiles now. Instead of having just this area, you say, well, my project's too big. Because I made a Shaw 256 encoder, basically.
Oh.
It did not fit in tiny tape out. It was only 500% too big.
Okay, too bad. Yeah, that would be Bitcoin miner then.
Yeah. Well, it was a Bitcoin guy who actually mentioned it, and I was like, how would you do that? I've never looked into it, so I made one, but I haven't taped out because too fast.
Yeah, I committed my designs to tiny tape outs too, and the 8 kilohertz limit was like really like the.
Oh, it's terrible.
Heavy.
It's
heavy limit, and now we are free with like 1,000 times the speed.
Yeah, and there's more I/O. You've got 8 bidirectionals on top of the 8 and the 8, and the clock and the reset are dedicated. So
nice.
Yeah,
it was always like, oh, come on, now I have only 7 bits in the clock.
Yeah.
So we have a question from the audience. For what kind of products would you advise to look into Tiny? I assume tiny tape out.
Tiny projects. Basically, I've been thinking of tiny tape out as a proof of principle. Some people have been doing like CPUs and stuff like that, and you can get really tiny CPUs in there. But a few of the projects actually break them out into pieces. Okay, this is my ALU. This is my blah, blah, blah. And so you get to try each of them. Unfortunately, you can't chain them. You can't say tie the ALU to this other project. That would be super. But the point is you can basically prove that each bit works. And then later, if you're doing an MPW, if you're actually going on a shuttle, stick them all together and go.
Probably you can even like control it externally, just turning off and on and buffering like the
right. Okay, do this operation.
An external register, and then
so you're the slow bus.
All right, nice, cool project. Looking forward to the results.
I have a question. Do you play the guitar?
Yeah, terribly.
Come on. It's your time to shine.
I'm gonna rock it out. Yeah, no, but I was surprised. The biggest surprise for me was how the signals come out, because I've never really looked at them. You start electronics and you're like, I'm going to make a guitar pedal. Yeah, distortion. I had the easiest one. Just
it's already distorted.
so great. But when you're looking at the signals, the biggest troublemaker is the FAC chord, the 83. It has these harmonics in it. Whatever you do, I mean, it's really. It basically has 2 harmonics. It has the second harmonic. So you've got the 83 and you've got 160 whatever at the same time, and it looks like 160 whatever. So that's why on the tiny tape out 3.5, I'm actually looking, 160. That's still E. It's just an octave up. It's like pressing 12, right?
Yeah, that's what I'm wondering about, that because sometimes you get like a sweeping between the over and undertones, and sometimes even like the overtone is like louder than the main tone.
Yeah.
And that's like, I mean, if you just want to tune, it's still like the note.
It still works.
The same note. Yeah.
As long as you identify it. Yeah.
But then if you get sweeping, you might get some fuzzy in between. Yeah.
Oh, I didn't put them in the presentation, but I've got a ton of images, captures from the scope, and it transforms. You've got and then it mushes together, and then there's your bass frequency.
That's cool. Okay, great. Do we have any questions in the chat? I don't think so. Okay, yeah, that was all.
Don't be shy, people.
Okay. Yeah, let's continue with you, Deshipu, then.
Okay.
I just picked the people today. Yeah, sorry, Pat, that I just pushed you forward, but you did a great job.
Well, thank you. And this way I can actually listen to the presentation.
Yeah,
you can relax now.
We will put the links in the description of the stream if you're rewatching it, and or afterwards you can check it out to Pat's channel and to the GitHub repository.
Yeah.
Okay, my turn then. So, if you watched previous Makercasts, you know I have made this. I have now a nice case for it. This robot. This is the budget version. So this is the actual project that I want other people to build. And it's now one server is disconnected, wherever. It's basically the simplest four-legged walking spider robot that you can build, the cheapest one. It uses like the cheapest parts out there. Not that interesting. But then I found in my drawer some old servos from long ago when I was still playing with other things. And I thought, okay, why not make a robot with those servos? And those servos turned out to be 2-gram servos instead of 9-gram servos. So I made this one, which is basically the same, except it uses a HAO instead of an ASP32S2. And it instead of Wi-Fi, it has infrared remote thing for controlling it. I can make it stop, or I can make it turn, or whatever. Anyways, so I've shown those before, but then recently, guess what? I found another servo in my drawer, and that was this one.
Oh, yeah, that's huge.
Right. So I decided to now. I had 100% one. I have 50% one. So now I need to build a 200% one. So if you are thinking about building robots, there is a very good bit of advice for you. Start small. Smaller robots are much easier. It's because of the so-called cube law. It basically says that as your size, if your size grows twice, then the weight of your robots grows 8 times, because that's 2 to the third. It's 8, right? Yeah. Anyways, so that means that a robot that has super tiny servos and is super tiny can actually carry much more weight, counting in the weight of the robot, and can use much simpler to use materials than a big robot. As a case in point for this, I used plywood for the legs, because I thought, okay, those legs are too big. I don't want to order laser cut parts from China this time because the shipping will cost too much. I will just cut them myself by hand from plywood, because I had some plywood in my drawer.
Did you use a coping saw, like, or
I actually used a scroll saw, because I have like a tiny scroll saw, and halfway through it started to release blue smoke. So I actually finished with this.
Oh, shit. You did it manually, man.
Yeah. So and you know, I already have a case in point. This is one leg segment that had to be replaced, because basically what I didn't, because you know, the plywood is actually vertical to the gravity, so that's fine. That should be fine. In terms of the weight that it has to carry, it has the right orientation to carry that weight, right? Because it's the thickest in that way. But what I didn't anticipate is that it's going to do this.
Oh, yeah.
So it's basically twisting this leg in, and plywood is very springy material, so this twisting is really bad for so the robot, it is walking. I can show you in a moment, but it is wobbling to the side.
Oh, so it's drunk.
Right. So that's the problem. If you go bigger, you need to change materials to denser materials to one, actually not denser, to ones that have more strength compared to their weight.
Also, power consideration should be like substantial. You
Yeah,
get some
that's why
glowing wiring. Oh, okay,
you
yeah.
can compare. There is a single
Yeah.
LiPo battery in here because it has charging built in, and
So
there
they're
are
in parallel.
two big LiPos in here, and they don't actually have charging because charging two LiPos in series is actually pretty complicated because you have to balance them.
Yeah.
So I have like separate charger for RC models.
So they're in series?
Sorry?
The batteries are in series?
Yes, the batteries are in series. If they were in parallel, then one would discharge more than the other.
Oh,
And
yeah.
because the resistance, internal resistance of the battery changes,
Yeah, but
one
don't
would
they balance
discharge
each
more
other?
than the other,
But
like
they,
very quickly.
I thought
It's-
lipos that were in parallel basically self-charge
yeah,
themselves if
they
they were
balance
close enough.
themselves because they're shorted.
Yeah, basically they discharge each other.
But they're charging each other at the same time.
Right. So I didn't want to get so complicated. So there is a back converter in here that's
Okay,
gets that
yeah, switching.
down to 5 volts, and then it works out. So that's much easier setup in terms of complicated electronics. I could do parallel and then balancing in there. It's possible to do, but it gets complicated pretty quick, and I just wanted to see if those servos can even carry these weights and if it will even work. Right, and as Simple Electronics points out, you also get stable voltage. It doesn't change as the battery discharges. So it's actually nice to have higher voltage and regulate it down. Back converters nowadays are super efficient. They're like 80-90%. So it's not even getting hot. So yeah, but you do run into those problems that you didn't have with the smaller one. And of course, I also didn't want to do like the previous one, the small ones. They use as the body. They use the PCB itself.
Nice.
So the PCB is part of the physical construction of the robot.
But
Here
the
I
legs
didn't.
are like acrylic. The legs.
Yeah,
of
this is
the-
plywood as well.
No, I mean the smaller one. That was acrylic. The legs.
No, yeah, the legs are acrylic,
Okay. Yeah.
but the body itself is just a PCB.
Didn't you have a version where the legs were also PCB?
Yes, I do. I have those legs.
So does they
where
see?
I made the at least the last section of the leg from the PCB, because I put a
Nice.
switch at the end. This is a
Oh,
switch
wow,
for SD card detection. So it's very soft. It's very weak spring in here. So you can tell when the leg is touching the floor or not. So you can, for instance, stop when it's about to fall off the table.
Cool.
But yeah, I didn't really do much with those. Yeah, and the small one, of course, has legs made out of PCB as well, because I just didn't care about laser cutting them. It's small enough to just order a PCB. That's
cool.
it. Yeah, I'm thinking now for this either to also do acrylic or to go like full aviator thing and use aluminum.
Oh wow!
I could use aluminum 2.5 millimeter aluminum sheets basically, and you can still cut it by hand, right?
Oh, you want to cut it yourself? I just wanted to ask if you have like a CNC somewhere hiding or.
Yeah, I could. I mean, Electro does CNC cutting.
Yeah.
But you no longer order it through the website. You have to actually send them the design, and they will send you the quote.
Oh,
So
okay.
it's a bit more involved. Maybe I will do it.
PCBWay does that as well. I used it recently. You can just upload a step file and so on. You get a quote, and then so I think it's quite new.
Yeah, so it's a learning thing for me. it's
Cool.
exploring new materials, basically. Yeah, I completely didn't take into consideration the fact that it will be.
You can even SLM 3D print from LM.
Yeah, so that's another project I have for this robot, the medium one, because it has the same leg configuration as the robot from Cyberpunk 2077.
Yeah,
the flathead, the drone that you have in there. It's exactly the same leg configuration, just the shape of the legs is different. So I'm now thinking, if I can easily change the shape of those legs, and it's just question of changing programming for the sizes of the leg. That's just two variables in there. I could make it look exactly as flathead with just a face mask for the flathead face. So that's another project I have in parallel. I already have those acrylic legs on order. They should probably arrive next week, and I will see how similar to flathead I can make it.
Cool.
But that's more like a art project than engineering. This is more engineering thing. Oh, I didn't switch it off to show how it moves. So you can see actually the servos move much slower. And for now, I made the steps shorter to debug it a bit easier.
But the servos, they can even they're strong. They can have 5 kilograms or something.
Yeah, that's 2.5, I think. But
2.5. Okay, yeah.
But still, but the robot is pretty heavy itself.
It can poke. It can poke a hole in your hand.
Yeah, this is the if you put your finger
don't do it, please.
then you can actually get pinched. So this is the level where it actually starts getting dangerous.
Oh.
And I don't know if in 2 years I'm not building a 400% one.
Yeah.
With I don't know, hydraulics.
Simple says there are servos that can carry 40 kilograms. So that might be cube long.
I know. I'm aware of those.
Imagine the legs on that.
Yeah, I'm not. So experimenting with servos. There are also recently I found there are servos that are, because those are like hobby servos. You give them PWM signal and they just move to that position, and you don't get any feedback from them. So you don't know what position they are starting in. You don't know what force they are using to stay in that position. You don't know what speed they are moving at. So it has to be hard-coded in the code that is controlling it. Basically, there is no input. This robot is blind, and
So you don't even zero them when you start up?
Yeah, I do zero them to the initial position, but you don't know in what position they are before you switch it on, right?
Okay.
They just go to the position you tell them.
And you use limit switches, or you just go all the way zero and then?
No. The servo itself knows in what position it is.
Right. Okay. Right.
So you just tell it, go to that position and hold it.
Yeah, but
and it does that.
Basically, you have but
you don't know when it reaches that position. So initial zeroing is actually on a delay. So that I'm sure they are all in the right position, and then I can proceed from there. Just guessing, having estimates of how long it takes for it to move.
And it's designed so that it's a tripod. I mean, when one leg's up, it's stable.
Yes, exactly. So it also tilts a little bit to the sides to remove the weight from the leg that it's about to rise, to move the center of gravity a bit.
Can you go
So
high
there
enough
are
to
actually
like
three
harness
motions
air?
that
Would that work?
it's moving all the legs all the time backwards at a steady pace, and then one leg at a time it moves it forward in a step. And before it does that, it tilts a little bit to remove the weight from it.
So it
That's
tilts with
basically
it puts the opposite leg out and then falls that way.
right. So it always puts makes a step with the leg that is the most backwards, the most in the back. So basically, that's the whole algorithm in there, and it's the same gait that cats use when they are stalking their prey, because that's the gait for legged animal that lets you stop at any moment, even if you have a leg in the air, you can stop still because it's statically stable. Basically, I can do trot on this, which means it moves two legs at a time that are on diagonal.
Even with the big one?
The medium one moves fast enough to pull that off. So it can move those two legs before it falls.
Yeah, cool.
Basically, it's falling all the time, but it manages to move them fast enough to not.
You need a flying wheel with to keep like a gyro.
Oh,
to
no.
keep it straight.
No. Oh, even with this robot, I'm not taking inertia into account, because inertia makes everything so much more complicated. You
So
don't want inertia. Like
Just
the fact that
eyeball it.
servo
You just
at the
need
end
to
of the
eyeball
leg,
it.
it's already bad design. I should have put the servo in here and
Yeah, true.
use like one of those, you know, the levers like this to transfer the motion to the, because then the servo is close to the rotation point and you get much less inertia. But I just wanted something mechanically.
Yeah, this is simple. Basically.
Yeah.
Cool.
I got this, the 507 mechanical movements. I don't know if you know classic, because I wanted to play with this stuff. I'm really not that great with the mechanism stuff, and I was like, I need to talk to a puppeteer because I don't want to have my motors where the action is. They're too heavy. But
yeah, exactly. You want the motors as close to the base as possible. And also there is this thing, but then there is, for me, it's a complication because I would need bearings of my own in there. So I would either have to make them or use ready bearings, and bearings are not that cheap. So it also increases the price of the whole robot. By using the servos in this way, by the way, you shouldn't use them because this is actually putting weight sideways on the axis of the servo. So this is also not like a kosher way of doing this mechanically. You should have a second femur in here supporting the other side of the servo.
You know what? You need Bowdens, and all the motors are just on the base, and that's all.
Right, and one motor, and just transfer all the it exists. There are those like that.
Sophisticated clockwork with one motor.
And they do pretty good, like 6 legs.
Jamie Menzel did the design of that. I mean, he basically built his whole YouTube channel, YouTube career around walking robots.
Yeah, the Strand Beast thing, and
yeah,
you know, you can do that, but yeah. So another thing about this configuration, you can't really turn around without the legs slipping. So it can do proper walking, but only forward. And when you are turning, you turn like a tank. Basically, move legs on one side faster than legs on the other side, because it cannot move the legs sideways.
Can it just tip over and push one leg like when it's diagonally?
Yeah,
like that?
you could do things like that, but you know, generally you don't have this That was a conscious decision to make it cheaper.
Mm.
But you still get the, to calculate the inverse kinematics for every leg. So it's still interesting. You still are learning the mathematics behind the
Speaking of puppeteer, did you consider just making like a controlling device where you would like basically puppeteer it and record what you're doing, and if you have like figure out a movement that would work for the robot, just playing that back or keeping it like in the base and the database of movements, and then
about 5 years ago, when I was maybe longer, 7 years now, when I was just starting with building robots, I had no idea about Arduino. I had no idea about any of electronic stuff.
Yeah.
And I just one morning I said, I should build a walking robot. And the way I approached this, I found from how they are called, one of those electronics shops. I found a servo controller that allowed you to record motions.
Oh, cool!
Like it was Atmega based thing that just did PWM, but they included like software that allowed you to like record macros basically on it. And I thought, great, I will use that. That should. What could possibly go wrong, right? It turns out that walking is much more complicated than you can record by hand. It's like all those little motions, like you have to move all the legs backwards while tilting the body, while raising the leg.
Right, it's a claymation nightmare.
Those kind of add up in complexity. So I didn't manage to do anything. Like you can do dancing, you can do like or waving with a hand, or roll over maybe even, but you can't really do complex
just
things.
Add some wheels already and let the legs just dangle in the air.
I have one robot like this with wheels at the end. The Logicoma from Ghost National Arise.
Oh no, sorry. I watched. I think I don't know if I even watched all the Ghost in the Shell.
So they have those Tachikomas and other robots like that. So Logicoma is the one that has really big wheels. So I could actually make a model of that. And it's somewhere in my drawer. It's in shambles. But it has like continuous rotation servos at the end.
Yeah. Oh yeah. Okay, I know which one do you mean. Okay, yeah.
Yeah, so but I haven't programmed it for walking.
Okay.
I changed its brain like 4 times now and still didn't get it to walk. Programming is always the worst part for me, because I'm a programmer by job, by day. When I finish my day job, I don't have the energy to keep programming.
Question about the PCB. Why didn't you use the PCB for the body on the big one? Was it because it's too heavy?
Because it's too big and I'm too cheap.
Oh, you want 10 centimeters JC?
Because I was playing with these and I was like, would this be better than plywood? And I'm not too sure, but I think so.
Would, and if I used like the 4mm thick PCB,
and then you put some copper and fill.
It's even better. In JLC PCB, you can buy aluminum PCBs.
Yeah.
Oh shit! How much is that? I think you're better to go to the PCB Way. Actually, does milling and stuff now. You can just send them a design.
Also Electro. I actually usually order from Electro because I like them better.
Might be
and also I have Fab Labs and hacker spaces in my town. I just I'm not good with people, so I didn't research very well what I can actually get.
Hey, can I submit online and just you do it?
Exactly. I will happily pay some money if I don't have to talk to someone.
Did you try Isla? They have like, I mean, there are some coupons around. You probably got one on the Hacker Day thing from Tore. Did you get like a coupon PCB? There maybe you can try a bigger board there, because that's not like there is no like a jump from
it's
import
just
or
not,
whatever.
it's not that I'm so cheap. I just want to keep this thing affordable.
Okay, yeah,
for
sure,
people
yeah,
to build.
yeah.
And laser cut,
You got
like
this.
in the end, I would laser cut this.
Yeah,
And still, laser cutting something even from acrylic or something is way cheaper than a PCB. That's why
Yeah.
I don't do LEDs out of PCBs anymore, unless I need to put a switch on it, because just laser cutting from acrylic is much cheaper. And if you think about what's happening in the PCB fab, it actually makes a lot of stuff. You use much less toxic chemicals for
And
it.
less steps.
Yeah.
But do you have?
It's
Bitluni, I
more
think you
bio
have a piece, a
friendly.
CNC that can go through aluminum, right? But I've got one of those little 18 whatevers, those mini cheapo CNCs, and I think it's good enough for acrylic, not for aluminum. But I would like to try. I'm just scared of the mess.
So the problem with CNC and acrylic, because with laser you don't have that problem. With any mechanical cutting, you have the problem that it gets hot.
It melts,
and it melts. And then it melts on your tool and clogs up your tool.
Oh shit! Okay, maybe not.
Right. It's like turning copper. If you look for like accident photos from people trying to turn copper, you see people like wrapped around the glass. It's not pleasant. It's that there is one particular accident that's called degloving. You don't want to see the degloving.
Okay.
What is that?
You don't want to see the photos of that.
Okay.
Yeah, the searching for accidents is probably something I don't want to do in general. It's like,
Right.
okay,
Big warning for anybody who wants to do this. But then it makes you think twice before you do something. So there is a plus side on those. Anyways, Bitluni, your turn.
Oh, my turn. Okay.
Yeah, what are you up to?
What I'm up to? Yeah, that's spontaneous this time. But I did a few projects. I mean, last time I was on the Makercast, I think I showed the super cluster, which was basically in RISC-V thingy. And what I did is we can take many of those and put them on a bigger one. Unfortunately, like this is not okay. That's like stacked. There's like
that's not even the final form.
No. So like the last blade is missing. So this is like you can see. Okay, yeah, that's the cluster blade, because there are also two RISC-V that are controlling the 16 on top of that. So on each blade there are like 32 RISCs, and yeah, on a complete array there is like 256 of those RISC-Vs, and you can see they have a different, like slightly different RC clock, and at some point it's basically random. But I didn't manage. I tried 2 streams. People are frustrated. I'm frustrated. I didn't manage to make it work so far. So this project is a little bit delayed, and those pink LEDs. They make my eyes ache. It's really like, I think there is like a ton of UV emitted from that, because every time I have this like next to me, it's quite a lot, because that's like 20 milliamps times 256 and 50% duty cycle. It's like really, really bright all the time. And,
Are you tanning?
Yeah, probably. So this is the supercluster, and you can see it receives like a lot of expansion slots. So it requires more power. Yeah, I have like some nice images how that heats up here. So that needs already like 2.5 amps to just run this with the blinky LEDs. Yeah, 1280 GPIOs that are that are accessible with 256
in front of your solar cell, and that way you can.
And you have 256 ADC channels that can like work at the same time. So I might do like some funky project like a brain interface or the sonar scanner stuff. So, and while I was waiting for this project to be done, I thought, okay, this is so complicated. This is so hard to assemble because you have like this surface mount and you have to align it properly. That's like 1.27 millimeter pin pitch connectors, and it's hard to assemble.
So I usually plug this in before soldering. Then I'm sure the spacing is correct.
Soldering, but you plug it in and then what do you solder first? Like the top,
like the
in between
corner pin.
Yeah. how do you solder in the center here when it's plugged
in?
No,
you solder the 2 pins at the edges. And then it's aligned.
True, to align it. But actually, it doesn't really matter. You can really eyeball it and it still plugs in. So apparently it's not, I never had like an occurrence of this like 16 things where it wouldn't fit. So with a little bit of force. But it's really hard to make, and I think people want to enjoy that, and that one is complicated because it's like a pyramid scheme. It has like 16 on each of the devices, and then there is a bigger RISC-V underneath that, and there is even one more level where all the bigger ones are connected to. So there are like 2 buses on top of each other, and there's like a 3-level thing, and it's really complicated. And I thought, okay, if some people want to like play around with that, I made like a simpler design, which is basically you can get this assembled from JLC. It's very simple, even like without the connectors. The connectors are basically a gimmick, and that's like 32 of those with a smaller footprint. That's like the QFN version, and they have like a red LED because it's less power and so on. So I even used a different like pin assignment, so you can use up to 16 pins from each of the RISC-V and have like 8 pins for the bus and 8 pins as GPIOs. And this time I thought about it to put the SPI on one of the GPIO buses. So you have like the register, the complete register with the peripherals actually on the GPIOs that can be put to the extension port. So you can basically even make like a VGA card or something with the SPI. So I did it. It's fast enough. Otherwise, it's a little bit hard. You can still make it, but it's a hard without any crystal, because I wanted to use any pin. I think you can even use an external crystal. So there is one gimmick with these. They can't be completely assembled I don't think that they can, because there is like this here in the center. You can see there is like this is the bus. So you have to solder, like, I can't show it. Let me grab a pin header. Okay. Okay. So
that's under.
So these are soldered first, because you need like to get it from the top, and then
do you have to snip them?
No, because
what are those connectors? They look like old ISA or whatever.
Yeah, they are similar. They have like 1/10 of an inch pin pitch, but they have enough like of a standoff. So if this is sort of like that, you can still like plug them in. It's a little bit tight fit, so you probably don't even need to solder.
Why'd you stick it in there?
So like that, and there is like you can see there is like enough space so it doesn't collide, and you can even use like old IDE cables to basically put them all on one bus. So you can even either plug them in on a like longer board or whatever, or just use a ribbon cable to connect more of these like in chain.
What's the upside of having that header stuck in the middle there rather than next to it where you could actually have it assembled?
The PCB is smaller.
It's is that a 2-layer?
It's 2-layer.
Okay, so maybe it's a trace thing.
It fits like that's no. I think one side is 10 centimeters, so you can get it really cheap. And if you look at this, because it has like some, so I don't know if that shows. Basically, there is like on this side you have the bus, and you need to connect like 32 MCUs with the bus, and it has like to be sound. And on the other side you have like all the GPIOs. You can see everything is filled with traces. Every space on that board, like on both sides, it is filled with traces. There was no space whatsoever except like between the connectors, and I thought, okay, I will just do it this way. I mean, we can change it anytime.
Hackers are going to make them, then fine. But if you want to make them assemble them in mass, I think it'll be a problem.
Probably. I think. I mean, it doesn't need to be final. Like we can like make it wider still on this side, but then it wouldn't like tile, because now it's tiling, and you have like the distance between all the LEDs is the same. You have now a full character of 4 × 8 pixels on that. So like that's why the bigger design is like that, because you can basically run a text something on that.
Well, then it would be a hell of a lot more wiring. But if you rotate them, if they're 90 degrees compared to the other connectors, top and bottom, then you can still do your tiling.
Yeah. Wait.
It's a lot of wires that go far, but
what do you mean? Like these like here on the top, or what? Like this one, like programming connector?
Yeah, that's it. That's what I mean.
Yeah. I have the power lines going up there. So I don't know, maybe it would fit. I wasn't sure. I just put it like that. Maybe it's not the final design, but nice input. Yeah. I think it could be easier to do it, but
and the connectors that are supposed to go into those slots, they need those edge plated things, and they're different on each side.
What do you mean with edge plate?
Okay, so they're dual sided, right? So I have a connector that sits into that slot. It's got metal on both sides to get into that, and it's a 1.6 millimeter board. It's like a standard.
Yeah. That's just a regular edge connector. You can. So that was the idea, to have like anything that you plug in can be basically ordered from a fab house, assembled, and then you plug it in, sound card, graphics card, whatever, like peripheral card. That's just like a computer, and you have like easy extension. So 4 cards should be enough for everyone.
What's the space center to center of those connectors? I mean, how much vertical space do I have on my boards that I'm sticking in there?
We can measure that. I think
15 millimeters.
It's more. Wait. Oh, the space between is not 15. Let me measure that so I can tell you. Okay, so Okay, I have 20 millimeters, and between the connectors should be no, that's 10. It's only 10. So
It's 10.
VGA, like something like VGA would fit, but not more than that.
Well, you
And
can
we'd
always,
have to agree to all put our components on the same side because we're going to have collisions.
you can
Yeah.
always put one on the edge.
Yeah, one on
connector.
the edge with the fat connectors.
Yeah. Yeah, I don't know. I mean, I will just that's what I made so far. It's like
Pretty cool.
now
Yeah,
I
3
just
years
need
from
to
now,
code,
we
and
will
it's the
be
hardest part.
cursing you for inventing a standard that we have to use now.
I thought of using ISA standard, but there's like the connector is like really crowded with stuff that you don't need. Like the address bus is 16-bit, and there's like plus minus 12 volts, whatever. And
Yeah, for sound cards.
on this one you can pick two different voltages because they're the risk. Basically, these are compatible with 3.3 and 5 volts, which is really nice because then you can basically do 5-volt peripherals or 3-volt peripherals run from them. So you have like two different voltages that you can pick from. So 3.3 and another one that you run.
Maybe.
Yeah. That was one of the projects, and I'm too lazy to do the code. Currently, Charles Lohr is working on the USB for these risks, and I already made boards that are basically waiting for this low speed USB just to have like yeah.
Oh, it's going to be bit banged. It has no
Yeah,
support.
it's bitbanked. It's working already. So
Okay.
there was no doubt that it's possible because they're quite fast with 48 megahertz. Yeah, Charles did in many sessions, like he worked his ass off to get this like working, and it's finished now. But now you have like to upload the firmware using like HIT device or something else. He went for the HIT device. You can do like a DFU or like a driver update, firmware update protocol, or like your own protocol. I wanted to do like a web uploader for basically your own driver on the web USB, because then it's not grabbed by any driver in your system, and then it would be easy to upload. But you have like to get the firmware on that
The
in
first
the
time,
first
yeah.
place before you can like. So I wouldn't like put this like on the market or whatever before I have like a really trusty firmware, because once you bricked it, you need like the programmer to like unbrick it.
And what's the programmer?
Oh yeah, that's the this one here. That's that's
So it's just SWD, SWC, or
yeah. That's one wire interface.
Oh yeah, you were sharing them between them all, right? At least in the first version.
Yeah. It can program, but not if you update to new firmware anymore.
It's a
The
one-time
release
only.
after that was horrible. I made it. I tried on stream, and basically nothing worked anymore. And that's one big issue, because you usually can't like talk to many at the same time, and there is like so Charles also mentioned, okay, you can like send it but not verify. You don't like request an answer or whatever. You don't poll, you just send, and just assume like, okay, now the flash should be written. So you have to wait for long period of time to be sure, okay, every MCU had the flash written, and I can continue with the next packet. So it's like a completely like separate attempt or protocol that you use just to write many at the same time. But I think that could be beneficial if you have like if you're in a production run and you have like a panel with many of the MCUs on their like board, and you want to flash the first firmware with USB or whatever. you want to flush them all at once. You don't want like to plug in individual ones and go on
like
with
through
that.
the panel.
Yeah, through the panel, like through the like, you know, the mouse bites.
Yeah,
where you have like
there you go.
one wire, power, and ground, and then you break it off, and it's programmed already. So that would be, so for cases like that, that mode might be interesting.
For the USB, do you know? I got a new keyboard recently, a mechanical keyboard. You know, the gamer, whatever, the keyboard people love their mechanical keyboards, right? I'm kind of there, but not crazy about it.
Yeah.
The point is, it has a way to program, you know, macros and the LEDs and all that shit.
Yeah.
But it happens online. I can't remember the site, but you basically go to a site and it talks to your keyboard through USB. And I don't know how that happens, but it's pretty interesting.
Yeah, that could be web USB. So
yeah, is that what you were talking about in terms of programming it?
Yeah, but I don't know. I mean, it's working on Chrome. I don't know which browsers else. I don't know if
only Chrome.
Only Chrome. Yeah.
Well, probably Brave too, because I mean it's a Chrome derivative, right? So
yeah,
and that's what I'm using.
Basically, what happens with web USB, you have like to access to the low level USB, but then if like another driver already on your system grabs the device, you can't access it. It's basically not allowed. And I mean, it's also restricted. You need like to have the signed website or whatever to be able.
Who has the keys to that?
There are many like disadvantages of doing it like that, but you can basically, if you have like your vendor specific device, that won't be grabbed by the system, and you can basically access like the descriptor from the browser and talk to your USB device like that, which is really interesting. If you're building your own devices, you can just make a website to flash it, to upload stuff, to do like upload gimmicks on that, images.
This was I can't remember the site, but it basically said, check your keyboard and you detect whether it supports this protocol, whatever it was, and then it'll program your shit, your macros.
Because it probably has additional USB device on the keyboard.
Yeah, it could be also like web serial. So if there's like a serial interface.
Yeah, well, whatever. It has the keyboard and then it has the additional thing to talk to.
Yeah. So yeah, that's that. I talked for a long time. I mean, I wanted to like talk about the thing that I'm like currently struggling with. That's the new VGA. People are asking for because I only sold like 200 boards of like the VGA for ESP32s, and now I made a new for the S3 version, because S3 is basically completely different to the older, like the original ESP32. Now I'm trying to program a driver for that, and it's in some ways better, and sometimes in some ways it's worse, especially the driver. There is like an LCD interface now, but you can't clock it with APLL anymore. So that's terrible if you want like VGA. Now, if who of you is familiar with that? Basically, you need like a pixel clock, which is not always like a fraction of your main like MCU clock or whatever, and then you get like jitter and whatnot. So you need like really clean clock. And on the ESP32, back then I hacked like even the APL to work like slightly outside of the specs to get like higher resolution and so on. And now you can't even like, it's not even rooted. You can't even pick the APLL for that, and there is no parallel mode for I2S anymore. There's only like the camera and LCD mode, but the LCD mode actually has like dedicated VSync and HSync, so you can do full 16 bits color, and it works also with 800 by 600, and with the like the ones from 8 megabytes PS RAM upwards. They support like an 8 octal PS RAM mode, which is fast enough so you can have like 800 by 600 from PS RAM in 16-bit. The problem is the driver is like in early stages, especially the Arduino version is like earlier version, and now we had like I experienced the problem that it was like desynced in the first rows, and now I found out why, because it's like really hacked that it has a slight delay between the frames, because it's like it's meant to work with TFTs which don't mind when like the next frame is coming, but in that case VGA is like really confused if you have like the clock like breaking for a fraction of a line or something.
But it's a forced delay where it's just waiting.
Sorry?
It's a forced delay where it's just putzing around, or
no? The problem is it's not like I think it doesn't work like continuously. They basically restarted in an interrupt, but they use like they have like the driver is written in like different layers, and there are at least like 2 abstraction layers that you can't even access from the API really, because it's buried like in like libraries. But the code is available, so you can actually look into that, but it's really hard. At the end I have to like re-implement everything to somewhat make it working. I'm not sure if it's working, if there is like continuous mode. I at least like that I had problems with the DMA. I can do like loop magic with DMA, but yeah, it will be a struggle, but when it works it will be really grand, because then we can like 800 by 600 in
16 bits, right?
16 bits is really good. Yeah. So, and that's basically it. I mean, the hardware is almost like done. It won't because you can basically use any pins. There is nothing that, I mean, I can only improve. Like if people say, oh, I need that pin for something different, then I will use a different one. But yeah, then that's cool. Breadboard friendly, and yeah.
Oh,
so
cool.
Work in progress, but that's
the breadboard friendly is really a nice touch. I love that.
Yeah, it's really squeezed in there. I don't know, it's not like perfect for the Wi-Fi, but at least you can plug something in like next to it. One row is free next to that.
Nice.
Yeah, that's about it. We are already like over 1 hour in.
So one moment, I just wanted to show the guy I was talking about.
Oh, the wheels?
With the wheels.
Yeah. Oh, nice, cool.
So basically, the Logicoma has those shields on the legs. So I made the whole thing out of acrylic, because it's in the stealth mode. You know, they have the like stealth mode in that movie where they are turned invisible. So that was the idea, and then we have the servos.
Okay, and they're direct driven, and
in the front because there, those are basically normal 9-gram servos with the potentiometer removed.
Oh,
okay. You just
you know there
just
are
drive
ones.
Yeah, exactly.
So you're setting
you tell them with PWM how fast to go.
Yeah,
and which direction.
Okay.
Yeah, it's super
really nice.
simple. I need to finish it one day.
Work in progress.
There's a servo connector. Is that just a decoration? That joint there, well, again, it's hard to point to, but right in the front, if you turn it, yeah, there between the 2 servos on the leg, is that doing something, or it's just the plus, the connector there, the white between the 2 servos?
You mean this servo?
Yeah.
Cord. That's just mechanical connection.
Okay, it's holding them together.
Both of the servos. I needed some piece of plastic, and it was already lying on my desk. So,
I'm not using it because I'm using wheels. All right. Cool.
Right.
Nice.
Sorry for the interruption.
Okay, no worries. Do we do a quiz? I don't know. People love quizzes, and I prepared one quiz with ChatGPT. We can just try it, okay? Okay, so let's it's quiz time, people. It's quiz time. So I asked ChatGPT to give me like a quiz for tech savvy people, and we have some interesting. I mean, the questions are really easy, most of them.
Have you tried turning it off and on again?
No. So let's start with the first one. If nobody gets it, I have like 4 options. So like who wants to be a millionaire, like, but I think they are solvable, especially with the peoples in the chat. They are solvable even without the options. Okay, so question number 1, people get ready. Which computer programming language is often referred to as the mother of all languages? Any clues?
So, are we supposed to propose answers, or how does
Yeah,
this work?
just shout it
I
out.
write them down,
Oh,
and
look,
at the end we can check.
No,
all
just
languages.
shout it.
It's
So,
Fortran. Fuck, man, it's C. Let's go.
no,
Oh, the mother.
not
We're really talking about the first one?
the mother. I don't know which the first one. Okay, I tell you the options: A, Lisp; B, Fortran; C, COBOL; or D, assembly. So which one? I didn't
I
hear
say
the
Lisp.
Huh?
Lisp.
Assembly was first, I guess.
Lisp is correct. The Shippo, you got it
What?
right. So
Lisp.
according to ChatGPT, Lisp is mother of all languages.
I
Oh.
can
I didn't
explain
know.
why.
I
can
have no
explain.
clue. We can ask it. We can ask it afterwards. Okay. Let's
Okay.
continue with the. No, yeah, in the chat nobody had it right, so there is no bonus. Okay, question number 2. What is the first video game ever created that allowed multiple players to compete against each other?
Pong.
I don't think Pong was first. I think there was a strategy game
Okay, here we
where
go.
you typed things into.
Here we
into
go.
the
The 4 options are, we have no early. A, is it Pong? B, is it Space War? C,
Yeah,
is
I
it
think that's the one.
Asteroids?
Yeah.
Is it D, Missile Command?
What was C?
C was Asteroids.
Shit, no. So maybe it was the B. I don't know.
Space War. Yeah. I'm
Pong is
sure.
the biggest known.
People have a delay in the chat. I will. We got 2-player is multiplayer. Yeah. Okay. I solve now. It's Space War. I don't know the game. Maybe if I see it.
Yeah, it's basically you type in the commands.
It's text, right? Yeah.
And you have to keep everything in your hand. In your head.
Like sinking ships or what? No.
Yeah, something like that. And it was
Okay,
it was on the mainframes.
Like
That's why
mainframe game. Okay, interesting. Yeah. Apparently,
well,
it's
mainframes.
a
There
hard
were
one.
like PDP 10 or something, but still.
I had like different questions in the beginning, and I said, come on, this is too easy. Make it harder. Okay, in what year was the first email sent?
Email.
What can you repeat?
First email. When was it sent? What year?
69, 70.
Okay.
Something
What
like
do you
that,
log
yeah.
in? The one with the closest year wins.
Okay, I'm saying maybe 73.
Actually,
A
okay.
bit later.
Atomic goes for 64. 77. Okay, according to ChatGPT, which can lie, we know it lies. It is apparently 71. That was before my birth, so I'm not that old. I'm old, but
Yeah,
not that
I'm
old.
younger than email. No problem.
Yeah, It was it's 71. So actually, we have close ones. Pat, you were close, and the Shippo, you were close as
citation
well,
needed. That's what we need with ChatGPT. Give me the site. Where are you getting this from?
Yeah. Then next one. No, I wasn't 10 years old, 71. I was born 79. Okay. I'm from the 70s, but not that old. Okay. Which company developed the first graphical web browser? Okay.
Mosaic.
Yeah.
Mosaic? What?
Mosaic.
Mosaic. That's why you have Mozilla, which is Mosaic Killer.
Oh, really? Okay.
Yeah, because it was the only popular browser, and they wanted it to kill it.
But
Yeah,
ChatGPT is going to tell us it was zero.
ChatGPT doesn't know it apparently because it claims it's Netscape communicator.
No, Mosaic was first.
Well,
it was graphical and was much earlier than Netscape was actually done by the Mozilla people, right?
Yeah. Okay. Tough questions. Okay.
Tough questions.
How many programming languages are officially recognized in the International Organization of Standardization?
One.
ISO. Is it 10? Is it 50? Is it 100? Or is it 200? I guess this might be wrong, this answer.
50. It's ISO. So they're not going to give us crab. They'll be a little bit behind.
I checked it. I fact check it. So ChatGPT claims it's 200, but where do I check that?
I don't know. They don't even have a number. There is no ISO. It just sounds like it's real.
It's a great quiz. It's a great quiz. Okay, what was the original name of the Java programming language?
Oak.
Really? I don't know.
Oak.
I wait for different answers. Any other guesses? Coffee?
Joe.
Joe? I mean, it's an island. Oh, Atomic, you used to know this. You were probably the one that sent the first email back then. Atomic is fully.
No, I think the first
into the
email was a support request.
Okay, it was actually Oak. Yeah, the Shippo, you got it right.
I'm so
congratulations. You are leading right now.
Oh yeah,
correct answers. You have 2 points, I guess, 2.5, because you were with Pat. You were close with the email. Who is considered the father of artificial intelligence?
They're going to say Turing.
A, is it Turing? Is it B, John McCarthy? Is it C, Marvin Minsky? Or is it D, Claude Shannon?
I would say B.
Yeah, me too. I'm not too sure. Shannon, they're just putting there because of information theory.
Who is John McCarthy? What did he do?
I don't know. I heard that name.
You heard?
Yeah, it's the name that isn't a trap.
Okay. Actually, I fact-checked it. It's John McCarthy. So you both get 1 point for that. It's not Turing. Turing didn't do anything with, but John McCarthy is one of the founders of artificial intelligence research. Okay, here we go. Question number 8. What was the first commercial handheld mobile phone? Any guesses? Wild guesses before I give you the options.
Motorola something.
Oh, okay. Is it A, Motorola Dynatec 8000X? Is it Nokia 1011? Is it IBM Simon? Or is it BlackBerry 850?
That's
Yeah,
ancient
I
shit,
will
man.
go.
Yeah,
I will
maybe.
go with Motorola as well.
Yeah,
Yeah.
Motorola.
I know
So Pat got
they
the
were
point. It was
created
Motorola,
specifically
actually.
for car.
Motorola thing. Guido, you got also 1 point. Nice. Okay. Yeah, I don't know. What does it? Is this the one from the 80s? Like the no, that
With
No,
a
was
it
suitcase.
wasn't actually portable. You didn't hold it in your hand. It was built into your car.
Yeah, and it had
Oh, okay.
and
That's
then
why
eventually you
Motorola.
could have the suitcase with you and say,
Oh, it
"Guess
is
where I'm
actually
coming from."
it is actually this brick. This is the brick
Yeah,
that you see
but it
in the
has a
80s
second
movies.
part that's
antenna
in your
and the
car.
triangles, right? The
Yeah, it has like it's like this.
yeah,
Like,
yeah.
you hold
Hey!
it like that, not like that. You go like that.
No, you hold it
Yeah.
like this.
But the good news is that the antenna is far from your head. See,
Yeah. Okay. Question number 9. What was the original name of the company that later became Yahoo?
Ooh.
No, this is a hard one. Okay, no guesses?
choices. Yeah, no.
We
Yandex.
are not that old.
Okay. Is it A, Backrub? Is it B, Excite? Is it C, Jerry and David's Guide to the World Wide Web? Or is it D, Archie?
Oh shit. Well, B and D are old school. That's about the right period, right? But it's C. It's like Craigslist things.
Yeah, Atomic also says it's Jerry and David. Yeah, it's the right answer.
What a horrible name.
Jerry and David's Guide to the World Wide Web.
No wonder they changed it.
And then they changed it to Yahoo. Maybe the site is still online, like what's a MySpace?
Yeah.
I have still a MySpace, probably a page somewhere there. Okay, last one. Who holds the record for the most lines of code ever written by a single person? Me?
Whoa.
Bill Gates. Come on.
Okay, is it Linus Torvalds? Is it Bill Gates? Is it James Gosling? Is it Richard Stallman?
Oh.
Shit, it might be.
If I had to, I would go with Stallman.
Yeah, me too.
Probably Atomic. Bitluni.
Is it Stallman? Is there a world
no,
record for this?
Richard Stallman. It's not Stallman. No. Who is Stallman? Do you know who is that person?
He's GNU.
No.
Oh. Yeah, I'm not so good with names.
Oh shit! Well, then he's going to say it has. I mean, it ain't Gates. It's
okay.
Linus.
Apparently, ChatGPT says it's James Gosling. Whoever that is, James.
The Hey Girl guy. Hey Girl, that guy. No, that's Ryan. Sorry.
Oh, he invented Java. Okay.
Oh,
Yeah, that's a lot of lines of code.
Yeah, probably. You have so much overhead in Java.
yeah, that explains it. He basically wrote 10 classes.
Yeah, I'm the record holder because I do so much copy paste. Okay, great. So apparently we have one winner. That's the Shippo. Congratulations, you have 3.5 points. Then we have Guido and Pat with 2.5 points, and then we have Atomic with 1.5 points, and some other peoples that all share the 3rd place.
Yeah, everyone gets a medal. Come on.
Yes, participation diploma. Okay, Thank you everyone for watching. It was a blast. I really enjoyed it. Looking forward to updates from Pat's ASIC project, and yeah, I really have also to check out the other stuff on your channel. The Shipu, we are looking forward to your world domination. At some point, you will be just coming to Maker Faire, whatever, followed by an army of robots.
Yeah, now I don't just need to install the razors on the legs.
Oh, okay. Do you have one with a laser, or 10-watt laser?
Does IR count?
Yeah.
I did try to make ones with infrared sensor and a laser, so you could
Yeah.
do like shoot each other.
Yeah.
So you
Robotag.
could build like a city in your room and have
Yeah, and
giant
we need
robots fighting in that city.
evolutionary algorithm training them to like.
No, like
compete.
remote control. But,
Okay.
but that I couldn't get, like the sensor is way too small to hit it with the laser. That's the
Yeah.
problem.
You need a bigger laser.
You just need a ball, like a ping pong ball, and that will glow up when the
Yeah,
laser
I actually wanted to get the
Diffuser?
thing that Roomba has, the original Roomba,
Oh,
on the
okay.
station. You know that there is like a conical
Oh.
mirror, and the sensor is below
okay.
this. But
It's like a
super
funnel
expensive.
for light. That's interesting.
Yeah, probably just a diffuser ball and the light
Yeah.
sensor
Yeah,
beneath
That's
that.
I
is good enough.
experimented with different kinds of diffusers. It's also difficult because acrylic is not transparent to infrared.
Oh, okay.
So it limits the materials you can use.
Okay, we are looking forward to your updates on that. And everyone, we will put links to the channels and the resources in the description afterwards, because I think it's sparse right now. And we are seeing each other on the next Makercast, which will be on the 2nd of July.
Yeah, in the X-Hein hackerspace.
Oh yeah, a
Oh, cool.
special X-Sign special. Okay, everyone, see you then. Same time, I think, or maybe earlier, I don't know. And thanks for joining. Bye-bye.
Thanks a lot. Cheers.
Bye-bye. And we are offline.